Hello friends, we will see how to find initial basic feasible solution to the transportation problem by using northwest corner rule. So we will go straight to the problem. So this is the first problem. Obtain an initial basic feasible solution to the transportation problem by using northwest corner rule. So the method that we are going to use is northwest corner rule. These are the factories, factory 1, factory 2, and factory 3. Destination 1, destination 2, destination 3, and destination 4. So from factory 1 to destination 1, if you have to transport 1 unit of goods, then you have to, the cost that you will incur will be 8. So if you want to transport from factory 1 to destination 2, 1 unit of goods will take will cost you 12 rupees and so on. Okay, so these are the cost cells. 8, 12, 44, 28, 4, 6, 0, 24, 4, 20, 32, 60, 36 are the cost cells, are the transportation costs. Okay, and the availability in factory 1, 13, 18 units, factory 2 is the 3 units, and factory 3, 30 units, and the requirement in the destination 1, 21 units, destination 2, 15 units, destination 3, 9 units, and destination 4, 6 units. So this is the problem that is given to you. So first of all, the first question that you have to ask yourself is, what is the objective? What is the objective? The objective is to minimize the transportation cost. So you have to find out what is your objective. That is your first step. So in this case, they have not given you profit matrix. They have given you the cost matrix. It's a transportation problem. So the objective is minimization. Okay. The second step, what you have to do is you have to see whether the data is balanced. So how do you check whether the data is balanced? Find out what is the total of requirements and the total of availability. So total of requirement is 21 plus 15 plus 9 plus 6 is 51. This is your total requirements. What's your total availability? 18 plus 3 plus 30, which is also 51. Therefore, since the total of requirements is equal to the total of availability, the data what is given to you is said to be balanced. Okay, and then we will be able to solve. So first step, always remember, you have to ask yourself what is the objective. If the objective is minimization, then you can go to the second step. What is your second step? You ask yourself, is the data balanced? If the total of requirements is equal to the total of availability, you will say that the data is balanced. So in this case, it is a balanced data. So straight away, we can go to find out the initial feasible solution. Okay, so I have copied the matrix, whatever is given to you. Now in this matrix, you know that these are the cost cells. So if you want to transport 1 unit of product from factory 1 to destination 1, you have to spend 8 rupees. And so matrix, you see what is the topmost corner cell. So we call it as northwest corner cell. So this cell, you must see how many units you have to allocate. You know the availability is 18 and the requirement is 21. The lower of the two you will allocate here. So that means from factory 1, you have transported 18 units to destination 1 means the availability will become 0. Whereas here, the requirement will get reduced to 3 because it requires 21 units. Already 18 units it's been transported, so it requires another 3. Whereas availability has become 0, therefore no more transportation is possible to any other destination because the availability has exhausted. So you have to cancel out this particular row. So now you see which is the next matrix. Which is the next matrix? Cost matrix. It is only this because the first row is already allocated. Now coming to the next one. In this matrix, which is the topmost corner cell is this. So here you have to make the allocation. You know the availability is 3 and the requirement is also 3. Therefore, you will allocate 3. So here the availability will become 0 and the requirement also will become 0. So once it has become 0, this particular column you have to cancel. Here also the row has become 0. So you cancel out this particular row because no more transportation to any other destination is possible. Okay, moving on to the next one. Next one is what? This is your cost cell. Okay, in this, how will you make that? So the topmost corner cell is this now. So this is 15 and 30, whichever is lower you have to allocate. So I will be allocating 15. So your requirement gets reduced to 15, availability gets reduced to 15 and your requirement becomes 0. Similarly, here I will make the allocation. This is 9 and 15. So which is lower? 9 is lower. So this becomes 0 and this becomes 6. And the last allocation, you will make it here 6 units. So this will become 0 and this will become 0. So this is your allocation for the balanced data. Okay, so what the method have we used? We have used the northwest corner rule method to find out the initial basic feasible solution. So if you want to know what is the transportation cost, how do you find the transportation cost, total transportation cost? 18 units you're transporting to destination D1 from factory 1. Therefore, the cost per unit is the transportation cost per unit is 8. So what you will do, 8 into 8 per unit. So 8 into how many units you're transporting? 18. Similarly, 4 units into 3 plus 32 units into 15 plus 60 units into 9, 16 into 9 plus 36 into 6. So 8 into 18 plus 4 into 3 plus 32 into 15 plus 60 into 9 plus 36 into 6. Correct. So this is the transportation cost. If you want to find out what is its value, you know that it it is 1,392 rupees. So that's the transportation cost for this particular problem. Now, the same question I'm going to modify because here it is a balanced data. Supposing the data is unbalanced. So what I'm going to do, I've taken the same matrix, but only one change. What is the change? Here, the requirement is 6. I made the requirement to 10. Why? Because I want to make the data unbalanced. So what is the total? 21 plus 15 plus 9 plus 10, I get 55. Okay, whereas here 18 plus 3 plus 30, this is 51. So what happens here? This is an unbalanced data. So if it is a balanced data, you know how to compute. If it is an unbalanced data, then what to do? So you know that the requirement is more than the availability. Therefore, since availability is short, there should be another dummy factory here. You should have a dummy factory and the requirement you have to put for the dummy 4. Only then what happened? It will become 55 over 55. So total of availability is 51. Total of requirement is 55. Therefore, you have to introduce a dummy row and the requirement availability should be 4 so that the total of availability will become 55. So same thing we have to do it here for the second one. Again, first step is objective. Second step, data is balanced or not. In this case, it is unbalanced data. Therefore, we have to introduce a dummy row. Dummy row we have to introduce because this total is 55, whereas this total is only 51. So to make them equal, to 55, what you have to do, you have to write here 4. So when you write here 4, this total of availability 55, total requirement 55, it becomes a balanced data. Now, what do you do for the cost? Because this is a dummy factory, there is no actual transportation taking place, the cost will be taken as 0. Okay, now it is a balanced data. So now we will start doing the allocation as usual. So how do? We will see only the cost matrix. In this particular cost matrix, which is the topmost corner cell, is 8. Here is the topmost corner cell. So 18 is the availability, 21 is the requirement. You have to allocate the one which is lower, 18 or 21, whichever is lower. So availability will get reduced to 0, and here the requirement will become 3. Since the row, this particular row has become 0, cancel out this particular row. All right. Now this row is eliminated. So which is the cost matrix? This is the cost matrix. So which is the cost corner, top cornermost cell is this. So 3 or 3. Availability is 3, requirement is 3. Whichever is lower, in this case, both are equal. So give 3. The requirement will reduce to 0. Availability also becomes 0. Since the row availability has become 0, cancel out this particular row. Similarly, this column has become 0, cancel out this particular column. Therefore, now the cost matrix, what you have is this. So in this, again, you give the topmost corner cell. You will be checking the requirement and the availability. What is the requirement? 15. Availability is 30. You can give the lower of the two. So your availability gets reduced to 15. Requirement will become 0. So cancel out this particular column. So now this is the cost cell. In this topmost corner cell is this. So you have to see the requirement and the availability, 15 or 9, whichever is lower. 9 is lower, give 9. So this will become 0. This will become 6. So because this has become 0, you have to cancel out this. So you don't have this particular. What is left is only this now. In this, you will give, this is the top corner cell, topmost corner cell. So you have to allocate 6 because 6 or 10, whichever is lower, 6 is lower. So this will become 0. Here it will become 4. And the last allocation will be 4 here. This will become 0. This will become 0. So we have made the allocation. Now we have to compute the transportation cost. How do we calculate the transportation cost? It is 18 into 8 plus 3 into 4 plus 15 into 32 plus 9 into 60 plus 6 into 36 plus 4 into 0. So I check 18 into 8, 3 into 4, 15 into 32, 9 into 60, 6 into 36, and 4 into 0. Correct. So find out what is the cost. We will find the cost. It is 1,392. Okay, so now what I have done, I made the requirements, the total requirement is more. So when the total of requirement is more, you are adding a dummy row and adding that availability 4 to balance it. Supposing if the availability was more, so same matrix only. So what I have done, so what is the total? You see 21 plus 15 plus 9 plus 6. So this is 51. Whereas this time what I have done, I have increased the availability. Availability is 61. So your availability is more than the requirements. So in that case, to make it equal, there should be a dummy column and its requirement should be 10. Only then it will add up to 61 and 61. I repeat, 21 plus 15 plus 9 plus 6 is equal to 51. 18 plus 13 plus 30 is equal to 61. So this is an unbalanced data. To balance it, you have to introduce a dummy column and the requirement should be equal to 10. So to work out this particular sum, what we are going to do, first one, again, you know what is the objective. Then you will check whether the data is balanced or unbalanced. In this case, it is unbalanced. And the third step is the initial basic feasible solution. So I know that the requirements total is 51, whereas availability is 61. It's not tallying. Therefore, I should write here 10. Only then this total and this total will tally. So I am making it balanced. So this is 61 now. This is also 61. So unbalanced data has been converted into balanced data. And what about the cost column? Cost will be taken as 0 because there is no destination and there is no transportation cost that you will be incurring because you won't be transporting any goods to the dummy destination. Right now, we will see which is the cost matrix. So this is the cost matrix. In this cost matrix, which is the topmost corner cell, it is this. So see the availability and the requirement. Availability is 18, requirement is 21. So the lower of the two, you will allocate to this particular destination. Therefore, this availability gets reduced to 0 and this will become 3. Now, since this has become 0, this particular row you have to cancel. So the cost matrix now, what is available is this one. So in this, what is the topmost corner cell is this one. You have 13 is the availability, 3 is the requirement, lower of the 2 is 3. So this gets reduced to 10 and this becomes 0. Since this particular column has become 0, you have to cancel out this particular column. So no more allocation to this particular destination. So now this is the cost matrix. Cost matrix. The topmost corner cell is this 10 or 15, whichever is lower. So 10. So this will become 0. This will become 5. Okay, since this has become 0, cancel out this particular row because no other allocation to this particular because there's no 0 availability. So you cannot transport anything to any other destination. Now the last one is this. So I'll give here 5 or 30, whichever is lower, it is 5. So this becomes 0 and this becomes 25. And then again, 9 or 25, whichever is lower, 9. This will become 0 and here this will become 16. So you will give here 6 because 16 or 6, whichever is lower. So this will become 0. This will become 10. Now, last you give 10 here, this will become 0 and this will become 0. So this is how you make the allocation. And then we will compute the transportation cost as usual. What is that? How do you calculate transportation cost? 18 into 8 plus 3 into 4 plus 10 into 0 plus 5 into 32 plus 9 into 60 plus 6 into 36 plus 10 into 0. So I repeat 18 into 8, 3 into 4, 0 into 10 or 10 into 0, 32 into 5 or 5 into 32, 60 into 9 and 6 into 36, 10 into 0. So how do you find this value? So it is 1072. So this is how you compute the initial basic feasible solution under Northwest Corner rule for a transportation problem. I hope you have understood. Thank you. Have a great day.